Hello everyone. The title of this video is Estimate and Approximate Roots, or radicals. Every exercise I do in this video are taken directly from a free online textbook at openstacks.org, and it's their Intermediate Algebra 2nd edition text. I'm in section 8.1, titled Simplify Expressions with Roots. And in this video, I'll be going over the exercises 19 through 26, and every single part as well. Parts A and B for 19 through 22, and parts A, B, and C for 23 through 26. And I do have timestamps for each of these exercises in the description below, the description of the video. So in the video here, when I say example 1, right, example 1 will refer to exercise 19. Example 2 will be exercise 20. All the way to example 8 will be exercise 26. Right. So you can use those timestamps to bounce around to different problems if you wish. Also, I would request that every time a new example comes up, that you pause the video and try to work on the problem yourself, right? Practice yourself first, and then watch me do it. Because if you're just watching me do these and not practicing yourself, well, you're probably not going to be learning much of anything. Alright, so the first exercise, exercise 19, we are asked to estimate each root between two consecutive whole numbers. Alright, so I have that written out here. So estimate each root between two consecutive whole numbers. So we're trying to figure out, so for number 1, part A, they give us the square root of 70. And remember, this symbol means the positive square root of 70, right? Because I know every positive number has two square roots, a positive one and a negative one. Just don't forget that when you see this symbol, an even root, they're asking for the positive one. So I'm trying to figure out what whole numbers this falls between. Is the square root of 70 between 5 and 6, or between 7 and 8, or 9 and 10? We'll see. Alright, so in order to do this, in order to answer this, I need to know some squares. Alright, this is a square root. I need to know squares to help me figure out where this square root falls between. So on a separate page here, I'm going to write some squares because I'm going to keep referring to this and for other problems with square roots. So obviously 0 squared is 0, and that's not interesting. So starting with 1 squared, the square of 1 is 1. Alright, then I keep going with the whole numbers. Square of 2 is 4. The square of 3 is 9, right? 3 times 3. The square of 4 is 16. The square of 5 is 25. The square of 6 is 36. The square of 7 is 49. The square of 8 is 64. The square of 9 is 81. And I'll go up to 20. Alright, the square of 10 is 100. The square of 11 is 121. The square of 12 is 144. The square of 13 is 169. The square of 14 is 196. The square of 15 is 225. The square of 16 is 256. The square of 17 is 289. The square of 18. 18 squared is 324. Right? Yeah, 324. The square of 19. It's 280 plus 81, 371. I do believe. No, 361. Sorry. 19 times 19. Yeah, 280 plus 81, 361. All right, and then the square of 20 is 400, right, and so on. Obviously, I could keep going with this. Now, look at what we're, so now remember what this means. If 1 is the square of 1, that means 1 is the square root of 1, and 2 is the square root of 4, and 3 is the square root of 9. 4 is the positive square root of 16, 5 is the positive square root of 25, and so on. We're looking for the square root of 70. So think about where does 70 fall in all these numbers here? 70 falls between 64 and 81. All right, so I'll write that here. All right, a little inequality. 70, the radicand, is between these squares, 64 and 81. And then taking the square root throughout, doing square root, I'll say take square root. We would have then the square root of 70 must be between the square root of 64, which was 8, and the square root of 81, which is 9. And here's what they're asking us for. All right, they're asking us to, hey, this root that we were given, between what two consecutive whole numbers is the value of this root? The square root of 70 is some number between 8 and 9. All right, so it's 8 point something. Now let me actually bring up a calculator, all right, and show you the square root of 70. All right, so I have a TI-84 Plus emulator here. You can use whatever calculator you wish. And I enter, square root of 70. And look at this. See, that's between 8 and 9. Like we said right here. It's 8.366, right? But it is definitely between 8 and 9. Okay. All right, now when you're trying to estimate square roots, you look at squares, right? 1 squared, whole numbers squared, 1 squared, 2 squared, 3 squared, and square. Part B, pay attention to the root. Right? We're trying to estimate the cube root of 71. In order to make an estimate of a cube root of 71, I need to know some cubes, right? Some third powers. So, same piece of paper down here. I'll just, these were squares. Let's do some cubes. All right, now I'm not going to go up to 20 this time. But, 0 cubed is obviously 0. We'll start with 1, right? 1 to the third power, 1 times 1 times 1 is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 4 times 4 times 4. 5 cubed would be 5 times 5 times 5, 125. 6 cubed would be 36 times 6, 216. 7 cubed, I'll just go to 10 here. 7 cubed, 49 times 7, 280 plus 63, 343. 8 cubed would be 64 times 8, right? 8 squared times 8 again. Would be 480 plus 32, 512. 9 cubed would be 9 squared times 9, so 81 times 9, 729. And then 10 cubed would be, 100 times 10, or 1,000. And obviously that list can keep going. Same thing with the list of squares, but when we're trying to estimate a cube root, we're looking at our cubes, 1, 8, 27, 64, and so on. Look at the radicand, 71. Where does that fall? Well, it's bigger than 1, it's bigger than 8, bigger than 27, bigger than 64, but not bigger than 125. Right? So 71 falls between these two cubes, 64 and 125. So I'll write that. Our radicand, 71, falls between 64 and 125, and then I'll just, like I did with the square roots, here I'm taking cube roots. Right, take cube roots, and then we have the statement, the cube root of 71 would be between, the cube root of 64 was 4, the cube root of 125 is 5, right? And that's what they want. That's what they're asking me for. The cube root of 71 is 4 point something, right? Is something between 4 and 5. All right, once again, let me put this off to the side here. I'll pull up a calculator and enter this cube root. Now this is a cube root. So I have to go to the cube root feature here. And we're taking the cube root of 71. And we already said, we said that this should be between 4 and 5. Right? So it should be 4 point something, and indeed it's 4.14, blah, blah, blah. Right? Wonderful. Okay. Next question. Right, so I'm going to still use this squares and cubes page. All right, the next question, same thing, part 2, number 2, part A. We're asked to estimate, the square root of 55. So look at the now it's square root. So I'm looking at the squares again, 1, 4, 9, 16, and so on. Where does this radicand fall between? 55. 55 is between 49 and 64. These squares. So once again, I'll write that. The radicand 55, falls between the squares 49 and 64. And so, taking the square roots of all these numbers, we get the inequality, 7 is less than the square root of 55, and that's less than the square root of 64, which is 8. And there we go. So whatever the square root of 55 is, it's between 7 and 8. Right? So when I enter square root of 55 into a calculator, it should be 7 point something. Right? So I'll enter that square root of 55, and you see it's 7.416, da da da. Wonderful. All right, and then part B is another cube root. So now to make a comparison, I'm looking at the list of cubes. Right. Look at the radicand, right? The expression underneath, the number underneath, the symbol. 119. And then look at all these cubes. 1, 8, 27, 64. 119 is between 64 and 125, these cubes. Right, so 119 is between 4 cubed and 5 cubed. So that means that, taking cube roots, that means that the cube root of 119 is between the cube root of 64, which is 4, and the cube root of 125, which is 5. Right? And that's what they want from us, right? Saying that the cube root of 119 is between 4 and 5. And once again, I'll pull up a calculator and enter the cube root. Let me clear this stuff. Enter the cube root of 119. And you see it's 4.918. It's between 4 and 5, like we said. Great. next question, number 3. Same stuff, right? 3 part A. We're estimating, the square root of 200. Pay attention. Once again, it is a square root. So I'm looking at squares. And then the radicand, 200. Now that's going a little higher up. 200 is between these squares, 196 and 225. 200 is between those. So I'll write that again. 200 is between, the 196 and the 225. And this leads me to the following statement. Now we look at the square roots of these numbers. Right? The square root of 200 must be between 14 and 15. Right? And that's what they want from us. Between what two consecutive integers is the square root of 200? And let's check that again. Take the square root of 200 on a calculator, and you'll see it's going to be 14 point something. Right. So here we are again. Let me take the square root of 200, and you'll see it is indeed 14 point something, right? 14.14. All right, wonderful. All right. This next, another 3 part B, another cube root. So once again, I'm looking at cubes, third powers. The radicand, 137. Looking at the cubes, 1, 8, 27, 64. Now 137 is between these two cubes, 125 and 216. Right, so 137 is between the cubes of 125 and 216. And then this leads me to the following statement. Taking the cube roots of all these numbers, we have 5 is less than the cube root of 137, and that's less than the cube root of 216, which is 6. Alright, so again, this is what they want. Right? This cube root of 137 is going to be 5 point something. Alright, let me enter that and check it out just to double check. So I enter cube root of 137, and indeed it is 5 point something, right? 5.15. It is definitely between 5 and 6, as we said earlier. Wonderful. Alright, moving on. Keeping the squares and cubes up, because again I'm seeing square root and cube root here. So number 4, example 4, part A, we're asked to estimate, what two whole numbers is the square root of 172 in between. So again, square root, so I'm looking at squares. Now the radicand, 172, that falls between these two squares, 13 squared and 14 squared, right? 169 and 196. So 172 falls between 169 and 196. And then looking at the square, then the same comparison can be made with the square roots of all these numbers, right? So the square root of 172 falls between 13 and 14. Right, and then let's double check that. I'm going to enter the square root of 172, and you'll see it is indeed between 13 and 14. Right, so the square root of 172, 13.114, blah, 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 right? Between 13 and 14. Right, and then once again, in part B, we have a cube root. So cube root means I'm looking at cubes. Right? Now the radicand is 200. Looking at all these cubes, 200 falls between 125 and 216, falls between 5 cubed and 6 cubed. Right, 200 is between 5 cubed, 125, and 6 cubed, 216. So we can make the same comparison with their cube roots. 5 is less than the cube root of 200, and at the same time the cube root of 200 is less than 6. So the cube root of 200 would be between 5 and 6. All right, and again, let's test that out. I'm going to take the cube root of 200 and it's indeed between 5 and 6, right? Closer to 6, but 5.84 something. All right. All right. Now we get into the last 4 examples. In the last 4 examples, they want us to approximate each root and round to 2 decimal places. So it's not the same as the first 4 examples. The first 4 examples just wanted, what 2 whole numbers was that root in between. Here we can just use a calculator and then round to 2 decimal places. I'm going to still say what whole numbers these will be between. The square root of 19 for part A. So I'm looking at squares. Now I'm just going to do the short version. 19, if you look at the radicand, 19 is between 4 squared and 5 squared, 16 and 25. So the square root of 19 will be between 4 and 5. Right, it's going to be 4 point something. Now what they want us to do this time, though, is actually enter it into a calculator and round it. This is the approximately equals button, not button, symbol. So the square root of 19 is approximately equal to, and I'll pull the calculator up again. We'll punch in the square root of 19. And I'm getting 4.358. Now they only want it to 2 decimal places. So they say it's 4.35, and then the one after that, the third decimal place, the 8, is 5 or greater. Remember, if the decimal place is 5 or greater and you're rounding, you bump the next one to the left. You bump the place before it up 1. And if it's under 5, you keep it the way it is. All right, so 4.358 would round up to 4.36 if I'm just doing 2 decimal places. Right? So I'm writing 4.36. All right, and then if you want to test this, if you take 4.36, right, take 4.36 and square it, right, raise it to the second power, 4.36 squared. This should be close to 19, right? It's not going to be exactly 19 because we rounded, right? This isn't exactly the square root of 19. It's around the square root of 19. And let's see what 4.36 squared is. And you see it's 19.0096. That's very close to 19. All right. So this is probably a good answer, right? Okay. So let me get rid of the calculator now and come back. And now we're working on part B. It's a cube root. The cube root of 89. So once again, I'm gonna tell you what whole numbers this is between just to keep practicing that, and then we're gonna punch it in the calculator and round to 2 decimal places. So the cube root of 89. Now I'm doing cube root, so that means I'm looking at cubes. Now looking at these cubes, 89 is between 4 cubed and 5 cubed, right? It's between 64 and 125. So that means the cube root of 89 is between 4 and 5. Alright, so when I enter the cube root of 89 in the calculator, I'll get around, 4 point something. It'll be 4 point something. In fact, I'll even start it with that. Alright, so let me bring the calculator back. And you can hopefully see my part B now over here. Doing the cube root. Right, cube root symbol of 89. And you see it's 4.46 are the first two decimal places. The third decimal place is under 5, so I keep the first two decimal places the way they are. So 4.46. 4.46 is our estimate, our approximation of the cube root of 89. Now we can test that out. Right, let me enter 4.46, right, our estimation of the cube root of 89, and raise it to the third power. This should be close to 89, and indeed it is, right? 88.71, that's close to 89. This is again, this is not exactly 89 because we rounded, right? If you were to take that number up here, right, the 4.46, blah, 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 if you entered that and raised it to the third power, it would definitely be closer to 89. All right, look at that. And again, even that's an approximation, right? This is the cube root of 89 to 9 decimal places. It goes out even further, but that's why it's not exactly 89, but very, very close. But yeah, so 4.46 is a good estimation to 2 decimal places, rounded to 2 decimal places. Now, part C is different than what we've seen so far in the video. Part C, I'm doing a fourth root, the fourth root of 97. So I'm going to do like I did earlier, and let's take a look at fourth powers. Right, now we're looking at fourth powers to help us estimate the fourth root of 97. Alright, so 1 to the fourth is just, 1. 2 to the fourth power, right? 2 times 2 times 2 times 2. Having the cubes up here might help. That's just 8 times 2, that's 16. Right? 3 to the fourth power is just, 27, 3 cubed times 3, so that'd be 81. Then 4 to the fourth power is 4 to the third, 64 times 4 again. Alright, which would be 4 times, that'd be 240, 256. 240 plus 16, 256. And then I'll stop here at 5 to the fourth. I'll stop at 5 to the fourth. And that'll be 125 times 5 again, right, which is 625. Alright, so there's some fourth powers. Now again, you can keep going, do 6 to the fourth, 7 to the fourth, whatever. Look at the radicand. 97. 97 is between these two fourth powers, right? 97 is between 81 and 256. So that means the fourth root of 97 will be between, the fourth root of 81, which is 3, and the fourth root of 256, which is 4. So the fourth root of 97 will be 3 point something. Alright, so I'm going to enter this, and then we're going to round to 2 decimal places, right? The fourth root of 97 will be approximately 3 point, and then we'll get 2 decimal places. Alright, calculator. Alright, now I'm entering a fourth root symbol. Let me clear all this stuff. So if I want the fourth root, I got to do this and enter the 4 where the index is. Great. Fourth root of 97. And you're going to see it's 3 point something. And we're asked to round to 2 decimal places, right? It's 3.138. The third decimal place is 5 or higher, so I bump the second decimal place up 1. So 3.14. The fourth root of 97 is approximately 3.14. And let's test that out. Let's take 3.14 and raise it to the fourth power. And this should be close to 97, right? It won't be exactly 97, right? It's 97.2. But that seems like it's, seems like 3.14 is a reasonable estimate of the fourth root of 97. Great. All right, so let's continue. Question 6. So part A, we're back to a square root, and then all the questions from here on out have one square root, one cube root, and one fourth root. All right, so square root of 21. Now this is going to be between, if you look at that list of squares, right, 4 squared was 16, and 5 squared was 25, right, and 21 is between those. So the square root of 21 is, between 4 and 5. So I know when I approximate it, it's going to be approximately 4 point something, right? And then let me enter it in the calculator. So square root of 21. 4.58, right? And it would stay 58 because the next decimal is a 2, right? So approximately 4.58. And once again, if you want to test this out, see if that's a reasonable approximation, take 4.58, and this was a square root, so I'm going to square this and see if we get something close to 21. And look at that, that's very close to 21. Not exactly, because we rounded, but it is a reasonable estimate. Okay. Then we have a cube root. Alright, now the cube root of 93, I'll tell you, is going to be between, if I look at the list of cubes, right, 1, 8, 27, and so on, the cube root of 93 is going to be between 4 and 5. Right, because again, 4 cubed is 64, 5 cubed is 125, and 93 is between those. So the cube root of 93 is going to be 4 point something. Right, this will be approximately 4 point. And then once again, bringing the calculator up, we'll enter this. Right, and we'll test it out. So I'm doing the cube root symbol now of 93. And yes, it is 4.53. The next digit is a 0, so it is 4.53. Don't need to bump that up. So yeah, approximately 4.53. And let's test this. Right, let's take our approximation, 4.53, and raise it to the third power. Right, because this was a cube root. Right. And we should get something that's approximately 93, very close to 93, and 92.959. That's close to 93. So 4.53 is a reasonable estimate for the cube root of 93. All right, then part C, got the fourth root of 101. So again, we haven't seen these too often, so I'll bring it back up. Looking at the fourth powers, 101 is between 3 to the fourth and 4 to the fourth. So this fourth root will be between 3 and 4. All right, so the fourth root of 101 is going to be between 3 and 4. So when I enter it in the calculator in a second, the fourth root of 101 is going to be approximately 3 point something. Alright, once again, I'll pull this off to the side. Let's bring the calculator up. Doing the fourth root symbol. And then 101 for the radicand. And yes, it is 3.170, so 3.17 when I round to 2 decimal places. Okay. And let's test that out. Let's test that approximation. Take 3.17 and raise it to the fourth power, right? This was a fourth root. And this should be close to 101. And it is, 100.98. That's close to 101. So this 3.17 is a reasonable approximation of the fourth root of 101. Great. Example 7. It yet again has a square root, a cube root, and a fourth root. So just as I've been doing, before I round to 2 decimal places, before I enter this in the calculator, I'll tell you what whole numbers it's going to be between, right, just to practice that. Now the square root of 53 is going to be between 7 and 8. Right, remember 7 squared is 49, 8 squared is 64, 53 is between those. So the square root of 53 is going to be between 7 and 8. So when I punch this in the calculator in a second, I'm going to get square root of 53 is approximately 7 point something. Alright, so let me pull that calculator up. The square root of 53, 7.28, the third digit is 0, so I keep the 28. Right? Don't need to bump that up. So 7.28. And once again, let's test that out. If I take 7.28 and square it, I should get approximately 53, something close to 53, and indeed that is definitely close to 53. Alright. Part B, we're asked to approximate the cube root of 147. Now, I'll tell you, 147 is between 125 and 216, right? 5 cubed and 6 cubed. So the cube root of 147 is between 5 and 6. Right? So when I enter the cube root of 147 in the calculator, I'm going to get something that's about, 5 point something. Right? So I know it's going to start with 5 point, right? And then we'll see what the rest of it looks like, and round to 2 decimal places. Right? So I'm doing the cube root symbol this time of 147. And yeah, 5.27. Now the third digit is 5 or higher, so I'm going to bump up the second digit. Right? So 5.28 would be the nearest hundredth. Right? And let's test that out, see if that's a reasonable approximation. Take 5.28. We're going to raise it to the third power, right? This is a cube root. And see if we get something that's close to 147. Oh yeah, definitely. That's close to 147. Alright, then part C is another fourth root. Once again, we haven't, because we haven't seen it all that much. Here are the fourth powers I wrote up earlier. 1 to the fourth up to 5 to the fourth. Now the radicand, 452, that's between 4 to the fourth and 5 to the fourth, right? It's between 256 and 625. So this value here, the fourth root of 452, is between 4 and 5. Right, so when I enter this into a calculator, the fourth root of 452, get an approximation, it's going to start off with 4 point something. Right? And then I just need to go to the calculator and figure out what that is. So again, I'm doing a fourth root. Right, so the fourth root symbol there of 452. And yeah, this should be 4.610, so 2 decimal places, the nearest would be 4.61. Alright, let's test this approximation. Take 4.61, and we're going to raise this to the fourth power. Alright, this was a fourth root. And see that we get something close to 452. And oh yeah, that's close, right? 451.65, that's close to 452. So that's a reasonable approximation, 4.61. Alright, great. So now last question has 3 parts again, question 8. And it's another square root, another cube root, and another fourth root. And I'll just write right away, part A, square root of 47. That's going to be between 6 and 7. So I know that when I punch in the square root of 47, it'll be approximately, 6 point something. Alright, so bringing the calculator up. Let's go square root of 47 Yeah, 6.85. Now the third digit is 5. The third decimal is 5. 5 or higher, so I bump up the second one. So I round that to 6.86 if I'm rounding to 2 decimal places. And again, you can test it out. Take 6.86 and square it and see if you get something close to 47. Right? And that's close to 47. That's good. All right. Part B is another cube root. 163 is between 5 cubed and 6 cubed, okay, between 125 and 216. So the cube root of 163 is going to be between 5 and 6. So when I enter this into a calculator, approximately, 5 point something. All right, 5 point something. And let's do that. All right, so we got cube root of 163. It's 5.462, right? So I don't need to bump up the second digit. It's just 5.46 when I round it to the nearest hundredth, right? The 2 decimal places. And let's test it out real quick. Take 5.46, raise that to the third power, and see if I get something close to 163. And indeed, that is close to 163. All right, then finally, one last fourth root here. What's the fourth root of 527? Well, the fourth root of 527, 527 is between 256 and 625, so between 4 to the fourth and 5 to the fourth. So the fourth root of 527 is between 4 and 5. So when I go to enter this into a calculator, the fourth root of 527 is going to be 4 point something. And let's do that. So the fourth root of 527 is 4.79. The third decimal is 1, so I keep the second decimal the way it is. So there's 4.79. Great. Let's test it out. Let's take 4.79, raise that to the fourth power, right? This is a fourth root, and see if we get something close to 527. And indeed, that's 526 point something. That's close to 527. So that 4.79 is a reasonable approximation of the fourth root of 527. Great. And that's it. Yeah, so just, the key here is to pay attention to what root's being taken. Square root, cube root, fourth root, fifth root. Just pay attention to that little number, the index on the radical symbol. And then you'll know if you're looking at, squares or cubes or fourth powers or fifth powers and doing comparisons to those. All right. So I'm hoping that watching me go over these 8 problems here with all these parts helps you out when you're working on similar questions on your own. And thanks for watching.